Bismillah Rahman Rahim. Assalamu alaikum and welcome to the architecture section of the course AR 309, which is about architecture and town planning. It is the lecture number 7. In today's lecture, we will learn about the principles of architecture. I have added a very short video just to base the discussion on. The video will help you to visualize the contemporary progress in the field of architecture, engineering, and construction technology. Please pay attention and feel the video.
As the world's population continues to grow, we're faced with the need for faster development in rapid construction on a massive scale. The building design and construction process is one that has relatively stayed the same for hundreds, if not thousands, of years. An architect or designer would create a vision for a structure, a civil engineer would create all the necessary supports and functions, and a crew of builders would ultimately construct the house or building. It seems simple, but one thing that the tried and tested process doesn't have on its hands is time. When time and efficiency become the driving constraint for construction, like what's being seen in areas experiencing rapid growth, oftentimes the only solution is manufactured housing. Like when China had to build a hospital in record time, they used prefabricated wall structures leaned up together to create one building as fast as possible.
Have you ever wondered or realized that how we have come to achieve this advanced form of building technology and construction within an unbelievable time frame? If the answer is no, so let's explore the efforts, theories, and humanly contribution behind this remarkable achievement in the field of architecture and construction. It has been majorly observed that all the successful implementations of practical work are supported by a repeatedly processed finance theories. Many of the ideas are then processed together and transformed in order to develop something new or unique. That is how the discoveries and invention took place in the past, and the same phenomena is still followed to perform creative processes. Inspired from the classic theories but in a transformed new form, however, the classic theories will always remain as core and fundamental, as they provide the base or foundation to all the relevant practical proceedings. So, let's move on to our very first slide: Importance of early theories and inventions in the field of architecture and construction. This slide defines the significance of association of past theories and principles with the practical implications in the field of architecture and construction. Before we move forward, we will get to know why theories are important. Theories provide us concepts to pen down what we observe and experimented and to describe or predict the potential or tentative outcomes. Theories allow us to get an overview on how to perform the practical and plan for further improvements. Theory is a tool that enables us to identify a problem and to plan a solution accordingly for altering the situation. The classic theories provide us with the strong ground to initiate the process, and we only have to think ahead of it. In order to bring uniqueness in our practical execution, just to realize the efforts made by previous men, we already have explored the construction history, and we must be thankful to the early engineers in the past, as we don't have to discover cement and other basic materials each time. Similarly, we must thank them for discovering unique construction techniques with frequent improvement for which we are utilizing advanced machineries and tools instead, as they are transform new forms, and we don't have to drag the massive stones as the Egyptians did. This emphasizes the importance of classic core theories or principles, which set as an important benchmark in the field of architecture and engineering. Furthermore, their periodical enhancement are mandatory For purpose, classic theories can be processed with contemporary human and environmental demands to shape the architecture accordingly. However, the basic principle will remain as same. Many thanks to the classical theories and inventions that have provided us with the base, and with periodic transformations, we are now able to execute rapid construction. And even with the complex new forms of architecture, which are obviously not possible without an extraordinary engineering support. Prefabrication and 3D printing are whole new form, an example of modern building technologies which significantly support the rapid construction. As an example, we have watched the video earlier. Moving on to our next slide. This slide has few glimpses of how architecture and construction has evolved through times. Displayed are few examples of evolution of important building materials and construction techniques. Starting from the Egyptian civilization, when the human based their construction by utilizing massive stones to build incredible masterpieces like Egyptian pyramids, which is recorded as an important addition in the field of architecture and construction. Moving ahead, the use of sun-baked mud bricks then became popular and was recognized as more functional and provided an edge to construction practices as compared to the Egyptian techniques. Afterwards, in Roman times, the discovery of Roman concrete provided the whole new form to construction and enables the architecture and design flexibility. All the important building materials then adopted and improved throughout times, and we are still utilizing them in their finest forms, such as marble, mosaics, and tiles, as the finest form of extracted stone, red burnt bricks instead of sun-baked mud bricks, cement and RCC as advanced form of Roman concrete, and steel structures were developed in the modern times following the footprint of building material evolution and to enable the lightest structural weight for the construction of high-rise and complex architectural designs. Simultaneously, the construction techniques also have evolved and ultimately enables the ease of construction throughout the period. The displayed pictures is provided the scene down is provided to scene down the historic timeline of past efforts till the modern prefabrication techniques, which introduce the manufacturing of houses or buildings instead of constructing them on site, just to cut the time and cost. Once again, the association of historic mankind efforts in the field of architecture and engineering, along with their periodic transformations, has provided that how classic theories, fundamentals, and principles still plays an important role in the further advancement of building materials and construction techniques. Therefore, the association of classic principles can never be separated from the process of architecture and engineering. Moving on to the next slide. In this slide, we will come to know about the very first theory in the field of architecture, which is considered as the foundation of all architectural writings and practices. Known as Vitruvius' principle of architecture, Marcus Vitruvius Pollio, commonly known as Vitruvius, was a Roman author, architect, civil and military engineer during the 1st century BC. He was known for his multi-volume work entitled as De Architectura. He was the first man in the history to record or pen down the important information or theories on architecture and construction. His discussion to perfect proportion in architecture and the human body got much fame. He was also the one who invented the idea that all the buildings should have three main attributes, which was firmitas, utilitas, and venustas, meaning strength, utility, and beauty. These principles were later adopted by the Romans. These elements are so important that they remain mainstays of modern architectural theory. Simple definitions of principle of architecture are: number one, truth and strength. Truth is the strength and refers to the establishment of laws. It further refers to purity and things without defects. Second is the purpose and utility. Without purpose, architecture cannot be created or developed. It also refers to the utilization of the building. On number third, it is form and beauty. It means balance between moral, social, aesthetic, and scientific aspects. I have also provided the picture of Vitruvius on the left side of this slide, and on the right side is the picture of the title page of his book entitling De Architectura. I will now try to further elaborate the principle of architecture developed by Vitruvius. By truth he meant an architect or designer must be sincere and truthful to his design and must incorporate all the goodness of architecture and design along with the association of respective and applicable laws. This will add the purity to the design and the building will become sacred. Secondly, the purpose or utility of the building must be identified prior to designing to ensure the maximum possible functionality of that particular building and ultimately to add maximum value to the design. This promotes the positivity in architecture and also considered as soul of the building, as it cannot be seen but greatly observed by the user of that building. Lastly, the beauty and aesthetics are the most important principles as they provide life to the dead. As buildings are greatly judged by its beauty and form, most of the creativity and efforts are therefore spent to enhance the beauty of the building. It is among the difficult tasks of today's designer or architects to maintain the balance between form and function of that building. Vitruvius' observations and theory became the foundation of all architectural theories in classic antiquity period. It is the period of cultural history between the 8th century BC till the 6th century AD, centered on Mediterranean Sea, comprising the interlocking civilizations of ancient Greece and ancient Rome. It is the period in which both Greek and Roman societies flourished and showed great influence throughout much of Europe, North Africa, and west of Asia. It majorly influenced multiple civilizations and helped them to develop further, which includes Sumerian, Assyrian, Egyptians, Greek, Roman, and Byzantine, and was also considered as the beginning of architectural evolution and got so much fame because of their originality and inventions. Such development were originally inspired from Vitruvius' theories, and specifically the architectural development were purely based upon Vitruvius' principles of architecture. After his remarkable contributions, construction and design considered as sacred practice of human civilization and gained so much attention, the concept of perfection and purity in the building designs became the compulsory attributes of constructing buildings. According to Vitruvius, architecture is an imitation of nature. As birds and bees build their nests, so human constructed houses from natural materials that have provided them shelter against the harshness of nature. Moving on to the next slide, principles of architecture and design orders. As architecture is generally thought to be a creative process where form and design are derived by a sudden inspiration, which refers to the memory of something beautiful seen in the past, and an interpretation of something that catches on attention in the present, or any other mesmerizing source. Such inspirations are then processed through a certain principles of design orders to achieve and develop more comprehensive concept or a solution. Further classification of classic architectural principles that have later evolved into six ordering principles and majorly utilized by the architects in developing the perfect architectural design concepts. They include axis, symmetry, hierarchy, datum, rhythm, and transformation. They will be discussed in details to expand the understanding and knowledge. So let's move on to the next slide. Number one, the axis. Axis is the most basic and most common organizing principle. Simply stated, axis is an imaginary line that is used to organize a group of elements in a design. In diagrams, axis is usually represented as a dashed line. An axis can be established by defining edges along its length. These edges can be simply lines on the ground plane or vertical planes that define the linear space. Alignment. Axis is mainly used to align elements. When elements are arranged around an axis, the design feels ordered and organized. Axis is majorly used to provide reference measurements and promotes organization and perfection. You may also have observed that the axis or origin in AutoCAD while developing the 2D drawings as bilinear directions, which is the x-axis and y-axis, or as horizontal and vertical growth of a 2D plan or an elevation. Moreover, in tagging a room, dimensions such as a room measuring 10 feet by 20 feet, the first measurement, which is the 10 feet, it represents the x-axis, which is also known as the length of the room, and the 20 feet refers to the y-axis, which is the breadth, width, or depth. The pictures just appeared showing the plan and elevation of a building. They are displayed as a realistic example to understand the imaginary utilization of axis. If you observe the pictures closely, the lines in the red color are representing the x-axis and the green lines are referring to the y-axis. While in the elevation, the vertical line in blue color is referring to the z-axis. Let's move on to the next slide. Number second is symmetry. Symmetry is when elements are arranged in the same way on both sides of an axis. Perfect symmetry is when elements are mirrored over the axis and exactly the same on each side. Balance. Symmetry adds balance to a design. When elements are same on both sides of an axis, the design feels harmonious. Asymmetry. Designs are asymmetrical if the arrangement of elements are different on both sides of an axis. Furthermore, there are two major types of symmetry. A is bilateral symmetry, balanced arrangement of equivalent elements from two sides of an axis, also shown in the picture. And number B is the radial symmetry. It has the equivalent elements balanced from two sides, two or more axes that intersect at the center point as shown on this slide. Let's move on to the next slide. This slide is displaying the example of bilateral symmetry. However, there are many examples of bilateral symmetry, but Taj Mahal, located in Agra, India, and Opera House in Sydney, Australia, are the best example of bilateral symmetry. And if you get to slice their plans from the middle, they are exactly identical from each side. This slide has few examples of radial symmetry, as on the left side is the Char Minar, which is located in Hyderabad, India, and the Great Stupa in Sanchi, India is on the right side of this slide, and they are equally the same from all four sides, as the picture are sliced through the red reference lines in this slide, just to assume their balance in the design. Moving on to the next slide. On number third is the hierarchy. Hierarchy is when an element appears more important in comparison to other elements in a design. There are further three main classifications of hierarchy. Number one is hierarchy by size. An element will appear more hierarchical if it is larger than other elements in a design. We naturally look first at the largest element in a design. It refers to the dominant architectural composition by being significantly different in size. On number second is the hierarchy by shape. An element can also appear more hierarchical if it is different in geometry than the other elements in a design. We naturally look first at the irregular shape in a design. It also refers to the visually dominant with respect to the form and shape. Lastly, hierarchy by placement. Last but not the least, we can place elements in more hierarchical positions within a circle. The center is the most hierarchical place. The end of an axis is naturally more hierarchical than the other points along the line. It refers to the strategically placed objects to call the attention of viewers. Definition of hierarchy. A hierarchy is an arrangement of items, which could be objects, names, values, categories, etc., in which the items are represented as being above, below, or at the same level as another, as desired or depending on the priority of design and its importance in the set. This slide has few examples of hierarchy just to get the better understanding. As you can see on the left top side, it is the Kalun Mosque located in Bukhara, Uzbekistan. It has the multiple arches in the same line, but the arch in the middle is dominating by its size. It can also be taken as an example of hierarchy by placement, as the arch is placed in the middle to gather the attention and focus of the viewers. Just below it is the Military History Museum, located in Dresden, Germany. It has multiple geometrical shapes, but the irregular triangle pointed shape is dominating the design, which makes it perfect example of hierarchy by shape. On the right bottom side of the slide, it is the it is the El Castillo, located in Chichen, Mexico. It has a room constructed at the top of the building, which is also at the center of the building. Therefore, it is dominated by its placement. Let's move on to our next slide. On number 4 is the datum. Definition of datum. It could be a line, plane, or volume that by its continuity and regularity serves to gather, measure, and organize a pattern of forms and spaces. Or a datum is form which ties together or anchor all the elements of the design. It can be a line like a road with houses arranged in along its length, a flat plane, or even a 3D space. Few of these examples of datum are represented into the slide. As on the right top side of the slide, it has the Salk Institute located in California. This is a building used for research facilities and office spaces. You can see there is a balance of the buildings on either side of the axis. If you cut the waterway through the courtyard, you can see the balance between all the shapes are balanced and showing a perfect regularity and repetition. On number second is the Durbar Square located in Patan, Nepal. This is showing the vertical datum. As you can see, most of the buildings are reflecting gradation towards the top or the upper side. And on the number third, at the bottom of the slide, it has the Marine County Civic Center located in San Rafael, California. This shows the perfect example of linear datum followed continuously in a long row. Buildings with datum follows the principle of design in a proper and well-designed manner. In design, continuity is made by form or a shape repetitions. As long as the basic element is repeated with an ordered sequence, a pleasant pattern will be created and would be identified as a rhythm. The phenomena of such a visual attraction will generate a pleasant environment for living, working, and recreational purpose. Such a pleasant creation in a product could be valid to justify a good quality design. Let's move on to the next slide. On number 5 is the rhythm. In a design, rhythm is the regular, harmonious reoccurrence of a specific element, often a single specific entity coming from the categories of line, shape, form, color, light, shadow, and sound. Few are some examples just to get the better understanding of rhythm. For example, ancient Egyptian stonework incorporates a vast array of patterns and textures that, when illuminated by the intense sunlight of the region, creates an animated display of light and shadow that the effect was powerful, direct, and inspiring. The another example is the stone towers designed by Zaha Hadid architects in Cairo. The facades on the north and south elevation of each building within the stone towers adopts a rich vocabulary of alternating recesses and voids to enhance the deep revealed shadow lines that highlights the curvatures of each building within the development and animate the project throughout the day. As shown on the picture, also the you can see the plan of the building. It also reflects the rhythm. And on the bottom left side, it is the Center of Rhythmic Gymnastics Center located in Moscow. It is also one of the finest example of rhythm in architecture. Let's move on to the next slide. On number 6 is the transformation. Transformation is perhaps the principle that most deeply captures the processes of architectural design. It can also be the most difficult of the six principles to grasp by those who are not trained in the field of design. It's based on the notions that forms often derived from the past or things found in the nature or other sources can be transformed into something different through a process of manipulation. Often designers begin with the prototype or model form that they then begin to analyze and synthesize. Through the process of exploration, often involving trial and error, a final form is then achieved which has evolved from the original form but still shares some root characteristics. The transformation of any building or a smaller component such as a staircase is mostly done or required when the building is renovated to give it a new look or form or shape, or to change its utilization, such as the transformation of a school into a hospital. Furthermore, as an example, I have attached the picture of a staircase. On the left side, it shows its old form, before the renovation, and on the right form it has the transformed new form after the process of renovation or transformation. So this sums up the principles of architecture and the design orders of architecture. Thank you so much for your attention. Our next lecture will be about the qualities of architecture. Till then, Allah Hafiz. See you in live sessions.